If anybody is viewing the video after the fact, we were discussing this other textbook.
Yeah, which name is Spatial Data Science with application in R from Edzer Pedzma and Roger Bivens. And Edzer Pedzma is one of the authors of the SF package, and Roger Bivens was the authors of the previous SP package. Is also like author of the SPDEF package, which is a package that's under a spatial correlation.
Hot off the presses, huh? Published
What? Yeah, the boss have impressive resume. But the book is, I don't know. I think they try too much. It's hard to cover everything, and I don't know. And we are waiting for Jim. Let me see if he's here.
Yeah. Yeah, in many of these books, they're useful for scientists, starting with the definitions and then moving on to the applications. But I imagine it's frustrating for students just sitting there wondering, why are we doing this? The book seems to be in backwards order from what's interesting.
Oh, you mean like the spatial data science?
Oh, this one too.
Oh, this one, yeah. I guess, I don't know. It's difficult to, yeah, it's super difficult to, because you need, and yeah, I don't know. I like the tidyverse approach of think, that's try to help you build something very cool first, then going backward, explaining how you have built a cool thing.
Yeah.
I like this approach. Like you have it in R4 Data Science, for example, the book.
Mm-hmm.
You have it in a lot of, but it's hard to do. It takes time, like to build a perfect example that's provide enough to readers, and then like you show him like how you have done it. I don't know. I think it's a complicated topic, and yeah, I will be like very. It's always a question, like when I was teaching in the university, I always had the question like, should I go like for the classic computer science course, where you go for the boring, like what's data type, how to define the data type, which they do it a bit, but at least they start with a chapter like kind of hello worlds, and then finally bring the last topic. I don't know. It's difficult to organize it. I always like go back and forth, because like I feel if I start by showing them how to do it, like you can write a script and then just change the parameters or stuff like that, or like some other course, like there's this guy who is teaching like Bayesian statistics. Name is Richard McElrath, and he built a package to go with his book. So it basically like help you. Like the first, it teach you like how you can do it with this package, which is basically wheels around the Stan software language, and then at the end of the book you use Stan. But it takes a long time to build that, to first build something so the students and learners or academic can be enthusiastic and learning interesting stuff while keeping, let's say, like some help. And then when they go to their problem, which will always be more complicated than the example, can be autonomous. But yeah, it's super hard. I really admire people who can do it well.
Yeah, so speaking of which, we have spent several chapters going over a lot of useful definitions for folks who do work with this geospatial and geocomputational tools. And we are now going to plainly see a chapter about making maps with R. So looking at some of the learning objectives, we're going to explore the tools that we could produce maps in with R packages, discuss some of the motivations for the various technologies, and introduce some spatial calculations. Here are some of the packages that we're going to use in the code for this chapter. Admittedly, we're going to spend most of our time today talking about TMap, and we'll look at leaflet a bit as well, and maybe a tiny bit of map view. I did not get around to looking at map deck, but that's also out there. And to be honest, for folks in the audience, either here or in the video, I'm going to assume you already know about ggplot. Thinking about geography in a historical sense, the authors noted that we could go back to at least, this is circa year 150, a relatively famous map by Ptolemy. And they called it geography. I'm not even sure if the word existed back then. This is an artistic reproduction. And if you're curious about the original map, it can be found on its Wikipedia page. Fast forwarding quite a bit. In the previous decade, around years maybe 2013, 2014-ish, base R became really powerful in its abilities to graph some of this geometry, say shape files and other files. So say, for example, if we grab the US states shape file with the projection from a previous chapter, we run it through the base R plot function, and due to the various columns, we do get this wealth of information with just 2 lines of code. As the technology is rounded into place, we probably should think about science communication a bit. This line accredited to Professor Cynthia Brewer, poor map making can hinder communication of results. Folks in this audience are probably pretty familiar with Brewer, for this professor is well renowned in the geography community and has created the color Brewer ideas, and the code packages that deal with color Brewer stem from her work. And nowadays, the production of textbooks like this and the codes we're about to see have a lot of motivation that while software such as ArcGIS or QGIS may be preferred by professional analysts, our packages such as the TMap that we're going to look at today are easier for introductory endeavors. It's easier to get into. It's much more accessible, and it allows a variety of people and researchers to get into this kind of in a citizen science mindset. So TMap, standing for thematic maps, is a powerful and flexible map making package with sensible defaults. And as I hinted at earlier, this will be very familiar if you have worked with ggplot in the past. Like a lot of popular packages, it has a good vignette that's available to you if you're interested. And you could also go back to, this package was created by Marcin Tenikis, and you could go back to his original work and papers and see some of the motivations behind this. We're going to start off with the New Zealand shapefile, which is a callback to how R was created in New Zealand. We have a shapefile in the TMap package. We bring it up with a tmShape function. But oddly enough, if you run this code, it'll produce an error because the computer, your RStudio session, will be wondering, well, what do you want me to do with that? So for now, we could say, fill in the shapefile, and we could start to see our image here. We could also look at the borders, namely the polygons, as we're pretty familiar. And you'll notice that these lines of code are connected with the plus operator. We're thinking about these as layers, as we would do elsewhere in GIS and with ggplot for that matter. So likewise, combining the previous two thoughts, we could add the fill and the borders layers. The TM layers functions, they include the fill and borders that we saw above, bubbles, if you have some text or labels, and of course, like in previous chapters, we should think about rasters every once in a while. At this moment, I fully admit, I was like, what the heck is bubbles? So quickly added that code, and we realized we get some sort of centroids, at least in some sense.
It's useful.
On top of that, to get people interested in using code to make maps, there's an even more broad wrapper function called QuickTM, QTM, Quick Thematic Maps. What this does, as you can see, will bring up the shapefile, the fill, and borders all at once. And this is useful if you're trying to get someone interested in, say, the R programming language, and you can show them that you can make a map of New Zealand in one line of code, roughly. QTM also has the ability to add on layers. There is another layer of data talking about the heights, and we see some dots, it might be a little small on your screen, corresponding to some relatively tall mountains in New Zealand. At this moment, there are a lot of dots approximately in the middle of the South Island of New Zealand. The picture itself might not look great right now, but that's kind of intentional for how we're presenting this chapter. We could also realize that polygons is the combination of fill and borders. And we're going to use this version of the New Zealand map as kind of the default going forward in this chapter. And we should probably briefly think about the data type, run that through, and we realize we have literally a T-map object. Here in this map, we could add on another shapefile with the elevations. We can add on a raster file as well. This is not going to produce an error because we have essentially used a base map along the way. And we'll just give this a slightly different name. In addition to adding layers in kind of the ggplot mindset, we could think of the dplyr Magritte pipes and connect this with workflows that might be useful to us. So for example, we've seen some of these functions in the past. We take a union of the polygons. We're going to put a buffer around that, and that's going to become a line string object. In addition to the base map and this line string object, we tell the program to graph that particular set of lines, and this will be our new map. You could see the goal of this particular workflow was to get a buffer around the coastal borders of the country. Thus, if you are worried about jurisdiction or local government overreach, where that is, this is a quick way to show that in just a few lines of code. As a side note, I think on this particular page of our slide, I let the warnings and messages go through to kind of show you, the audience, that there are some warnings at this moment. There were warnings about the downsampling of data, and sometimes these legends do not necessarily fit in the plot area. In the future slides, I'm just going to go ahead and suppress the warnings and messages. If any of you are familiar with patchwork, the team map folks created a convenient function for if you do have multiple maps and you want to show them side by side. This is very easy to do with the team map arrange function. Skipping the warnings. So we see at the trio of maps on the bottom arranged side by side, kind of our workflow so far. We loaded the New Zealand map with the elevation raster on the left. In the middle, we have a buffer to highlight the coastal regions, if that's useful for us. And on the right, we have the point data for a few particular mountains that we want to emphasize when thinking about elevation. There's a lot to say about aesthetics. And if you have ever gotten to the point of asking questions like, how do you change the x-axis labels on a ggplot, you realize quickly what's available to you out there. And it's a similar feel here in Tmap. We could affect the colors, the opacity, the line width, the line type, and other attributes with our objects. This is a really quick introduction here, and I'll just pause here so you could get a sense of some of the possibilities.
And they are consistent with base R, LWD, LTI are all example argument in base R. And I think, I do not remember in ggplot what it is, but and core also, no? They are the same name, I think. Same name of arguments.
Oh, yes, indeed. You're right. These are virtually all the same as in base R.
So people can, if no, people know base R, they can pick up them quickly, I guess. I don't know if they are the same inherited or if they just use the same name.
Yes. If you have any old codes, this might be the newest one. Sometimes in the past, we used the size argument with line strings, but now are depreciated that, so they want line width.
Yeah, makes sense.
So in addition to how we could literally or explicitly tell the system what colors we want by name, when we deal with displays, we probably want to use a variety of colors. So let's think about how we could do that. As you can see on the graphs below, we have the data about median income, but maybe different ways to display that. In the first graph, we could have this broken down with like this should be 4 or 5 rectangles.
No, the color one is the second one.
Yeah.
The first one is color map 1, and the second one is color map 2.
Thank you.
I think.
And this is useful if you wanted to describe this in an easier way, such as lower income, middle income, higher income. You could also literally set the number of breaks as you see in the lower left map. And with the colors themselves, you could give them a sequential color palette. Now, part of the issue, as many of you would know, is when you're working with numbers like this, instead of having to determine an arbitrary number of breaks, you probably want to affect this by the numbers themselves, by the, in this case, the currency or dollar amounts, whatever they use in New Zealand.
New Zealand dollars? I don't know. I'm gonna check.
And we might have hinted at this before. There are more holistic ways of doing these breaks here. So we have these 6 images. I'll try to keep as much as I can on the screen at a time. The top left here is a setting called pretty. We could also deal with an equal breaks, which will take the numbers themselves going from the minimum to the maximum, break them up in equal ways. But if you look at the legend in the graph in the top middle, your audience might not like how you have these dollar amounts with a lot of significant figures. On the top right, we have the quantiles, breaking up the population and their data by their quantiles. It probably makes the most intuitive sense. A lot of studies have gone into this idea, and a popular way to do this in the field is called a Jenks break system. And that's, off the top of my head, I believe is a compromise between having like reliable numbers, but also having a good visual spread as well.
Yeah, it's sometimes called natural break. I don't remember why.
Thank you.
Other people may know that its name as natural break, but yeah. Which is not natural by any kind of mean, but
bottom middle, this is a smoother gradient if you treat the income as more of a continuous variable. And bottom right, a situation where it's much more obviously a categorical variable. So you could literally have a categorical style. The idea of with thematic maps is to make the coding as easy as possible for new learners. For folks that are interested, I think I got this HTML tip from actually one of you guys in a different book club. So I love how you could in HTML just have this pop down, and you could have the descriptions.
I have used it for quiz before, but I stopped.
Yes, exactly.
I don't know.
Yeah,
it's a good trick. You're right.
I do something similar nowadays in Quarto, but it uses more CSS. Once you get into the colors, you probably want some power over the customization. Well, I just want to once again highlight that we have this possibility with a categorical variable. We don't have too much time to spend on color theory, but what a sequential color palette does is start off with one color at the low end, another color at the high end, and in a sense builds the shades or hues in between. So you can see here in this example, we bring up a palette called blues, which will naturally assign a light blue color to lower numbers and a dark blue color to higher numbers in this example about population. There may be times, however, where you want more contrast. So there have been studies into diverging color palettes, where you have, in this case, greens in one direction, browns in another direction, and in the middle, just kind of a generic white or gray. Say in this example about median income, if you're trying to make a statement about this, the diverging color palette might more obviously show you regions with low income and regions with high income. As a side note, I've always had difficulty for some reason dealing with the color brewer functionality. I just found this function from the color space package much more convenient, even though it's probably the same thing. So that's why I loaded that package today. I have a generic slide and collection of thoughts calling elements. That could be a different word there. First thought, if you are in a geography class and you probably have a teacher that said your homework absolutely has to have a compass and a scale bar. This is one of my favorite features of the TMAP package. It's probably the easiest way to add a compass or a scale bar to an image, to a map. The elements by default would be on the bottom right of your map, but if you want to reposition that, we have a parameter there. And there are various other ways to customize that, especially with the scale bar, where you probably want to affect the numbers, the font, and the font size. Once again, due to the huge variety of customization options, we're probably not going to describe them explicitly each. I'll just keep this on screen for a bit so you could take it in. On the top left, we could add a title. On the top right, we have our borders, the polygons, and we could rescale that by a factor to stretch or shrink those. We could affect the background color. And if you're frustrated, you could just get rid of that frame altogether. There's some other arguments here, getting a little more finicky or deeper into the weeds, as we might say. Folks in this audience have probably used legend position quite often in their work. But this is once again to show that if you choose to work with TMAP, you are reassured that one, it's easy to get into, but two, when you want to customize or really polish your graphs, you will have the ability to do so. For the folks who want to make graphs very quickly, TMAP also offers themes. We have the black and white that we've been seeing so far. On the top right, classic, kind of reminds me of maybe a Edward Tufte book. On the bottom left, this one's called Cobalt. Kind of reminds me of journals or newspapers and how they present their information on websites on the internet these days. On the bottom right, there is an option for colorblind. I haven't really looked into this. I'm always a little more hesitant because there are many different types of color blindness. But nevertheless, if you're being careful as how you choose colors and want to be accessible to the audience, this is a quick way to help with your production. In making these slides, I decided just to keep the code and the map right next to each other and kind of imply what goes with what. You might have noticed that besides this one example, I did not put the titles on any of the slides because I felt that it would probably run into complications pretty quickly. And if you want to read more about that, there is a good discussion over here at Stack Overflow. Basically, when you want to move the title here in a TMAP setting, you have to consider the bounding box, not of the shapefile, but the bounding box of the plot itself. And my opinion is, if you are being very detail oriented and dealing with the bounding box of the plot, you might as well be working with ggplot and that level of detail there. So that's some of the features available as far as the coding of T-maps are concerned. Well, as you can see on the left side, we'll look at some of the applications in just a bit, but maybe pause here. Is there anything else you guys want to talk about?
I'm good. Good job presenting all of that.
Yeah, this is great.
There are times when you don't want to present just one country, or you want to present more information than that. Earlier, we hinted that with a map like this, with this elevation, we show some information, but it might not be in a visually pleasing way. So what we're going to do now is look at this elevation for New Zealand, in particular the Wampa Mountains in the center of the South Island, and see if we could emphasize that a bit more with an inset map. The workflow, which I tell my students, you do not have to memorize this. What we're going to do is define an area of interest, which again is a bounding box issue. You have to be pretty familiar with your coordinates and the number system.
Yeah, you have functions that get you the bounding box, but yeah. It's probably not the same, as you mentioned, it's probably not the same like the bounding box of the shapefile. It's not the same that the bounding box used by the T-map, but yeah. It's basically X-min, X-map. A bounding box is X-min. It's a min of both direction. But yeah, min and max. But yeah, it never works perfectly.
As you folks have mentioned in previous chapters, we've got to be careful with the coordinate reference system, the CRS. So just grabbing it from one of your shape files or data files is probably the most convenient. And we're going to save that column of coordinates for a second here. We're going to have a T-map workflow to create the inset map itself. The bounding box, as you can see, created from the previous chunk above, and some other features here. And the inset really doesn't help us much unless we have the overall base map. Putting things together using the base R function print on our, starting with the base map and bringing in the height map via the viewport. To be honest, I might have switched some of the words or descriptions at some point. But nevertheless, we could see the intention. We could zoom in on that particular group of mountains. And we could still have the inset map to tell the viewer what part of New Zealand we're focusing on. A very famous setting is whenever you're plotting a map of the United States, the default is the 48 contiguous states, but we don't necessarily want to always ignore Alaska and Hawaii. So we could bring those in as well. And I just want to emphasize that there is a Hawaii map, there is an Alaska map, and bringing this all together. But thankfully, thanks to the power of T-map, this is all done with relatively few lines of code, and could be done by someone who wants to work on this pretty quickly. Whether or not this is a pretty map of the United States is another question entirely.
Yeah, for those who work in the US, the Tigris package, I think, has a convenient function that do something similar also. We do not remember the name of the function, but yeah.
Oh, that's good to know.
Yeah, I think you have the same, like France, at least as now have the same, because France have a lot of ultramarine territory, and you want to include them, and you also like a package that does that. But yeah, you can do it also with T-map. So depending where you work, you should check like if some package do it. But for the US, the Tigris package do that.
Okay.
And it uses ggplot.
So now we're going to move into some applications.
Yeah.
Terminology is sometimes called choropleths, really, when working with these thematic maps. But for now, let's first look at facets, which in talk about data visualization and science communication, you may also have heard this called small multiples. That is, if you have multiple variables you want to express at once, so in this case, latitude, longitude, obviously, but also time and population. So we have 4 variables, which would, even a 3-dimensional graph would be troublesome to see, but we want to show the viewer what's going on. This faceting or small multiples is a very convenient way to do this. In the TMAP workflow, we add on a layer literally called TM facets. Now, depending on your data and the implied bounding box that you would get, it might shift the graph or stretch the graph a bit. So being mindful of that, you probably want to not use free coordinates and make sure that parameter is false. When I was working with this example, by default, this legend appeared on the right, which would have shrunk the graph horizontally. I did not want that. And in the TMAP settings, if you want to move the legend, you need these 2 lines of code. Oh, I should have mentioned like what the data is actually saying. We're looking at cities with populations of at least 10 million people. In the top left, we see that we have about maybe 10 to 20 cities there in 1970. But as we move into further decades of 1990, 2010, 2030 projection, we realize that around the world, more cities will achieve this distinction of having at least 10 million people. Nowadays, especially if you're displaying your data online rather than in a journal paper print, and animation may be the preferred way to go. I think from here on out, I did not actually run the codes live. Some of these have longer processing times, so that's just something to consider. But in TMAP, the convenience is the switch in the previous group of facets, we have the by parameter. In animated maps, we call it along. Once again, to keep your image still and your coordinates in place, you probably want to nullify this particular parameter. And once you have that compiled and saved in your workspace, you could export the file with a very convenient wrapper function here. So as you can see, not only do we have more cities that are achieving the 10 million population mark, we are getting bigger and bigger cities as well. At this point, the textbook authors wanted to show off a bit, and they also produced this map that shows the expansion historically of the United States, along with the population infill of the various United States. This particular bit of code would have been quite lengthy for our book club here, but I believe they have a page of our code somewhere in their files. But it goes to show you how powerful TMAP can be if you choose to work with it. Something that has been becoming more popular in recent years, at least in my opinion, are interactive maps. And you could at this point, tell your RStudio to just make all the maps you're going to see after this line of code be interactive. So if I bring up that third New Zealand map with the buffer and the point data, we get a map where we could zoom in and out, shift, etc. For the life of me, folks, I have no idea what happened to the colors or where the raster went. You could use a base map from popular services such as Open Street View, Open Topography, maybe some of the Esri tiles. Again, for some reason, in this particular example, New Zealand's gray. But at least you could get a sense of what we meant by the rest of the base map. One thing that surprised me, was really new to me, is you could combine some of the aspects that we've been looking at. If you have a facet of information, say here we have coffee production in 2 different years, you could put these interactive maps side by side and say, if I wanted to zoom in on Peru, this will happen in both maps simultaneously for our convenience. At this point, the code produces the facets, but keep in mind earlier, we told RStudio to make all maps interactive. There's a slightly different code if you just want to do this one map at a time. Combining some of that all together, map view is yet another wrapper function. This will get your shapefile, fill borders, and make it interactive with our zoom and pan technologies. I find this useful, once again, if you're trying to get people interested in the R programming language, and you can show them this is the capability we have with one line of code.
Tmap is also super cool if you for quick visualization. Sometimes you just want to be sure like what you have done is correct. So in one line of code, you have like this quick visualization, which is like for quick data exploration. Map view is awesome. Also, I think it's allow you more than one engine. So currently, all of what we have seen, I think used leaflet. But I think MapView also have MapLibre and other like a backend engine. And I think also Tmap, but I do not know if they mentioned that, the authors.
This chapter did not mention that too much now.
But yeah, if I'm correct.
At this point, the authors pointed out a more thorough example that has been done with MapView. Here we have breweries and other types of businesses in Austria, I believe, or a region around there. Oh, that's definitely Germany.
Yeah, MapView have MapDeck.
Mm-hmm.
Also, you can switch the platform you want. It's another JavaScript library.
Speaking of MapDeck, I really like this feature where folks over at MapDeck are building this so-called 2.5 dimensional view. So instead of having a heat map over your shapefiles, this might be more intuitive to your audience, where you can have a slanted view and maybe even set the angle so that you can have something that's arguably more engaging. And then finally, as we zoom out a bit, rather than using wrappers of other functions, a lot of this, as you said, tends to be based in Leaflet, which is arguably the most mature and widely used interactive mapping package in R. It's still a good compromise about having easy and accessible code, while it's really powerful because it accesses the Leaflet JavaScript library, and we'll see some of the effects here. As as a side note, Leaflet is created and maintained by a person whose name I admittedly still cannot pronounce, but he's over in Ukraine, and I just love this package quite a bit. Here we have an example of bicycles in the London area, and what Leaflet does, as some of the other interactive examples showed, is that we could zoom in on the graph. And of particular interest, if you notice, as I'm panning around and zooming on the graph, the same happens with the inset as well. So we could show the viewer a lot of information really quickly. As another side note, in case people are wondering how I got this into the slides, into our Markdown book, I went to inspect on the other example, and I copied and pasted the code for the iframe, and this literally put that into our Markdown document. Finally, as some of the folks here who work professionally are maybe already doing or maybe are looking into, when you want to present a lot of information to your teammates, your cohort, your clients, maybe not all at the same time, you want to give some flexibility, it's probably time to make a Shiny app. You'll have the interactivity, but map content is still feels static itself, so you might want some flexibility in dealing with the data acquisition or working with the data. And as I was implying, this is useful for making dashboards. Here we have another view of the Cycle Hire app. This is made by Robin Lovelace. We could once again do our interactivity and zoom in and out on the image. But we could also I might have messed that up. We could also affect some of the other information on the graph as well. That went right into the north or the channel here. So all this Shiny capability is out there, maybe not in this particular R Markdown book at the moment, but it is possible for us to do. Of people in this particular book club, when I was looking for resources, I came across this here, a pretty good, thorough example of building such a Shiny app. This is coming from Geospatial Health Data by Paula Moraga. And folks in this group, this might be the next book you're going to be reading if you're interested.
We already have done it.
Oh, okay.
But yeah, it's a difficult book in some places. The Shiny part is easy. I mean, Shiny leaflet is, but like the modeling part can be hard. Yeah. But it's a good book. But it exists, so I highly encourage people of doing it, but at least I have done it. Yeah. And the authors, Paula Moraga, have on our website plenty of tutorials with team app, leaflets, and a lot of. I was searching for it. I will copy paste, but yeah, she have plenty on tutorial. Our website is not perfect, so I have trouble finding it. But yeah, it's a great. She also like. Yeah, she also explained like she also include dashboarding, flex dashboard. So you can also include like having how to build a dashboard, link Shiny, the modeling parts. That this is a very full example. You're right. To provide everything.
We are running low on time here. Just to mention the end of the chapter, we have spent a lot of time looking at TMAP. I might have presented before. I'm a big fan of the ggplot2 capabilities in this realm and Leaflet, but there are other packages out there that have done a lot of work and have been really stable for working with map data. And for particular map types, there are some packages out there available for folks to explore. In particular, you folks on Twitter and other places might have seen Ray Shader by Tyler Morgan Wall, and they're making incredible 3D maps and animations using that package and that engine. And yeah, that's going to be chapter 9, folks.
Right. No, like I tried to find the link of the tutorial of Paula Moraga, but I can't. It's on the website, but it's not linked correctly. Like if you go on a website and tutorial maps, you will find some, but it's not everything. So I guess it's probably, I will copy paste it, but I think it's easier if you search on our GitHub because it's probably linked here, but I couldn't find it. I will copy paste it. So it's the main website paulamoraga.com does not link to our tutorial. So you have to kind of, which are different websites linked, which has linked differently. So it's kind of difficult to find, but yeah. And she's like, she also, at my level, she's also good with HTML, and you know she managed well. I think she made good work with managing the HTML, so the rendering of the leaflet is way better. With just a few pieces of HTML, this changed everything. I assure you. But yeah. Anyway, thanks, Derek. It was great. It's like a bit laborious, like you have a lot of options to present, but I think you do a good job presenting it.
Thank you. Thank you. At the end of the hour, we of course ask who is presenting next week. The next chapter is about the GIS software. So if any of you work with ArcGIS or QGIS a lot, that's probably your alley.
I have worked with both, but ArcGIS not the last 10 years.
And then the chapter after that looks like a lot of more general computer programming if you're interested.
Let me check. Well, I can be the one next week. I will also, because like even if like everyone knows QGIS and ArcGIS, but you have an introduction to Grass and Saga, which has old dinosaurs, but they are cool. I mean, I shouldn't say they are old dinosaurs because they are still maintained and people are still working on it and still improving. But I mean, at least for Grass, it was developed from the 80s, I think. So it's old.
We also have the issue that the last 4 chapters are applications, but they are really short. So we probably do not need 4 weeks on that.
That's good points. Mm-hmm. I guess we can wait a bit. Do we want to, well, let me check. Computation with
For one idea, I think I could just do 2 of them in 1 hour, then whoever could do the other 2.
Yeah, we could also do more exercise. We have option. Let's see, introduction. Yeah, it's true. The one from transportation seems long, no?
I forget, but not by number of pages, no.
Yeah, because yeah, but it's bring OpenStreetMap. Well, yeah. So we can say that. Let's say I have never read the geomarketing one, so I'm curious. Well, why not? We can say that. We can think, but like if people can check that for next week, and then we can decide. But I'm totally up to like if we can do 2 chapters at once. I think it's a good idea. What's our other take? Tony, Jim, Ryan.
Yeah, combine them. Sounds good.
Okay. Well, do some of you have question, remark, or are we good?
Nope, I'm good as well. Thank you, Derek. Nice
Well,
work.
thanks,
Good.
Derek. It was good presentation. Thanks a lot.
Thank you. Bye-bye.
All right, see you all.
Bye all.